Hey, this is Mr. A, and this is section 5.5, multiple angle and product of sum formulas. This is our last section in chapter 5, which is analytic trigonometry. And so let's get to it. We have what's called the double angle formulas, which is sine of 2 times some angle, or cosine 2 times some angle, or tangent 2 times some angle. You can see the sine of the double angle formula for sine is equal to 2 sine of x cosine of x. Cosine, there's 3 different formulas you can choose from. Tangent, there is a formula, but it has, oh no, a denominator, which makes it kind of stinky. And so let's take a look at this one. We have 2 cosine of x plus sine of some double angle. So what do we know? We go to our double angle formulas. So that equals 2 sine of x cosine of x. That's our equality. So what's in both of my terms is 2 cosine of x, and I'm going to factor it out, which means he's left with 1. He's left with plus sine of x is equal to 0, which means what do we know? We know that we have 2 different ways to solve this problem. We have this way, which is cosine of x is equal to 0, which is really, it's 2 cosine of x is equal to 0, but you divide by 2, it's still 0. We have this one right here, which is sine of x is equal to negative 1, because 1 plus sine of x is equal to 0. So I got to ask myself, where does cosine equal 0? Well, it equals 0 at pi over 2. It also equals 0 at 3 pi over 2. Where does sine of x equal negative 1? Well, that's just at pi. And so you can see how we have this double angle formula happening at each of these points. Oh, sorry. Where does sine of x equals negative 1 is 3 pi over 2. 3 pi over 2. So we have each one of these values, my bad on that last one, at 3 pi over 2. So we really only have pi over 2 and 3 pi over 2 because that is a solution for both of those. And obviously we could add n times 2 pi, which would give you every single angle you could possibly have to solve this multiple angle equation. Let's take a look at this, where we know cosine of theta equals 5 over 13. So if cosine of theta equals 5 over 13, let's think about what does sine of theta equal? Now take a look at the stipulation here. We are in the 4th quadrant. We are from 3 pi over 2 to 2 pi, so we're in the 4th quadrant. We're in the 4th quadrant. And in the 4th quadrant, the cosine is positive, but the sine is going to be negative, so it's going to be negative 12 over 13. So again, with one of these where we're given some 5 over 13 or a 3, 4, 5 triangle, make sure you find out your other trig functions. Okay. We also know tangent of theta equals sine, which is negative 12, over cosine, which is 5. So you can see how, what did I do? I found all of my values to help me out with my double angle formulas. Okay, so we have sine of 2 theta, that's equal to 2 sine of theta times cosine of theta. What is sine of theta equal to? It's negative 12 over 13. What's cosine of theta equal to? It's 5 over 13. And so you can see how with this double angle formula, we are left with negative 120 over 169 if you do that in your calculator. Okay. Well, what about our cosine of 2 theta? Which formula are we going to use? Well, I'm going to use this one right here. We can use any one, but this one's going to be probably the easiest. So we have 2 times cosine squared. Well, cosine squared squares these guys, so we have 25 over 169 minus 1. So you can do this calculator. You have 50 over 169 minus 1, and we end up getting negative 119 over 169. Okay, and that's your cosine of 2 theta. Well, what about our tangent of 2 theta? Well, our tangent of 2 theta is going to be 2 times tangent of theta. That's 2 times negative 12 over 5, all over 1 minus tangent squared of theta, which is going to be positive, because we're squaring it, 144, that's 12 squared over 25. Okay, and if you did this in your calculator and you found out the fraction at the end, we get 120 over 119, and that's what tangent 2 of theta would be. You could also have done this is tangent of 2 theta equals sine of 2 theta over cosine of 2 theta. And think of what sine of 2 theta is. Sine of 2 theta is negative 120. What's cosine of over 169? What's cosine of 2 theta is negative 119. Then those cancel out. The 169s cancel out, and we're left with the same value we got from our formula, our double angle formula. We can also derive a triple angle formula like this. This is a little bit more difficult, but we can work through it. It's sine of 3 times theta. So what do we know sine of 3 times theta is? It's sine of 2 times theta plus theta, and that's really 3 times theta. Now, if we think back to our sum and difference formulas, remember we had this sine of u plus v. Well, what did that equal? That equaled sine of u, which is 2 theta, times cosine of v, which is theta. Go back to your formula sheet. Cosine of 2 theta plus sine of theta. That was our sum and difference formulas right there. Now we can go to our double angle formulas. What do we know about sine of 2 theta? Well, that's 2 sine of theta. Cosine of theta times cosine of theta, it's cosine squared of theta. Okay, and this is a multiply symbol right there. My bad, that's not an addition. That's an addition right there. And we have cosine 2 theta. What am I going to use? I'm going to use this formula right here, which is 1 minus 2 sine squared of theta times sine of theta. So just kind of stay with me here. This is where it gets a little bit more difficult. You can see I have a bunch of sines, but I have this weird stinky cosine squared right there. What do I know I can substitute in the midst of this cosine squared is 1 minus sine squared. Why can I do that? That's your Pythagorean identity. And I have 1 minus 2 sine squared of theta times sine of theta right there. Okay. So let me distribute as much as I can. I'm going to distribute this 2 sine of theta. So we have 2 sine of theta minus 2 sine cubed of theta, plus I'm going to distribute this sine of theta, so sine of theta minus 2 sine cubed of theta. Take a look at what I have. I have minus 2 sine of theta, minus 2 sine of theta, that's minus 4 sine of theta. I have 2 sine of theta plus a sine of theta, that's 3 sine of theta minus 4 sine cubed of theta, and that is our deriving a triple angle formula. We can't go anything more than that. That's as much as we have right there. And so here we have our power reducing formulas. We have sine squared of x, and you can see it's moving down from the second power to the first power, cosine of 2 of x. And it moves it into double angle formulas, doesn't it? We also have an equivalency for cosine squared of x and also tangent squared of x. So these aren't different formulas. They're just giving us different tools to use. We also have what's called half angle formulas. This is when we have an angle which is less. And so let's say we have something like sine of 15 degrees, a sine of 15 degrees. Well, 15 degrees is not on our unit circle, but we have sine of 30 degrees divided by 2, so we could use our half angle formula here. You might say, Mr. Aiden, why can't I just use sine of 45 degrees minus 30 degrees and use my sum and difference formulas? You can. They are all equivalent. They're just different ways of doing the same thing. So let me give you an example of using a half angle formula. So here, using our half angle formula, we're doing sine of 105 degrees, which means that is really the half angle. 105 degrees is half of 210, so 210 degrees divided by 2, which means this 210 is right here, which means that guy is right there. It's just an equality. So that gives us plus or minus the square root of 1 minus cosine of 210 degrees over 2. 1 minus cosine of 210 degrees over 2. So we look at 210 degrees, we look at what cosine is. It equals plus or minus the square root of 1 minus negative root 3 over 2 divided by 2 right there. And so if you clean this up a little bit, we would definitely be the square root of 2 plus root 3 over 2, and that would be what it was. Whether it depends what quadrant we're in as well, doesn't it? because you can see the reason it's plus or minus is if we're in this quadrant right here, you can see we are going to be, you can see 105 degrees is in this quadrant right here, which that is in the second quadrant. What do we know about the signs in the second quadrant? Sign is always positive, so this is going to be a positive value. The reason they put plus or minus is you got to figure out what quadrant you're in. And so here we're in the second quadrant, which makes this sign of this angle positive. We also have what's called product of the sum and sum of the product formulas. And again, you're just plugging things in, simplifying them. Let me give you an example. So here we have cosine of 5x, sine of 4x. Can you see that this looks a lot like this formula right here? Which means u is going to be equal to 5x. V is going to be equal to 4x because we have 5x and 4x, we have cosine and sine. Which means we're going to rewrite this. We're going to rewrite this using the product of the sum formulas. And so this is being multiplied, that's why it's a product, and we're moving it to a sum. So sine of u plus v. So I take 5x and 4x, and I get 9x. Okay? Minus sine of u minus v. 5x minus 4x gives me x. And that is my rewriting my formula. You're just figuring out who's u, who's v, and you're plugging it into the formula. We also have what's called writing sums as products. Okay, so here we have cosine and cosine. So we have cosine and cosine in this formula. This is going to be u, 195 degrees. This is going to be v, 105 degrees, which means this is equal to 2 cosine of u plus v divided by 2. U plus v divided by 2. And so I hope you can see we have 195 degrees and 105 degrees, because that's u plus v divided by 2, times cosine of u minus v. So 195 degrees minus 105 degrees divided by 2. Let's do a little bit of simplifying here. So what's 195 plus 105 divided by 2? If you do that in your calculator, you get 150 degrees. If you take in your calculator 195 minus 105, that's 90 divided by 2, that's 45 degrees. Now you go to your unit circle. Cosine of 150, that's equal to negative root 3 over 2. Negative root 3 over 2. Cosine of 45 degrees. Cosine of 45, root 2 over 2. One of these 2's cancels out. We get negative root 6 over 2. And that is the exact value of these two angles together. And we use our sum to product formulas. A lot of formulas. Hope this helped. This is section 5.5, and we are done with chapter 5. See you guys.